Yes, good evening, all of you. Am I audible? Yes. Uh, any CR is there in the meet, or Saira just punch on your unofficial group? Ask everyone to join first. Okay. We'll wait for 2 3 minutes more, otherwise, we will start. Okay. Okay. So, good evening, everyone. Can we start with the session now? Yes. Hello. Can we start with the session? Am I audible to you all? Very good. Okay. So let's try to understand what type of problems till now we have solved in the fuzzy set. So first we have seen what is a crisp set, what is a fuzzy set, what are the properties of the fuzzy set. Okay, I'll be sharing the notes once I complete with this. Okay. Then we have seen how to perform the operations on the fuzzy set like intersection, union, complement, difference, algebraic sum, algebraic multiplication, bounded sum, and product of this. Okay. Then in the last session, we have also seen the problems like how to find out the lambda cut, okay, and the strong lambda cut. So all such problems we have already solved. Now, in today's session, we will be going for the two sets of problems, and if the time permits, I'll be completing the defuzzification. So that will complete our entire fuzzy set. What we can say, the topic. Okay, the theory notes regarding the fuzzy set I'll be sharing with you. So do not worry about that, but concentrate more and more about the problems. So can we start with the problem now? Yes. So today we are going to start with the fuzzy relation. So till now we were talking about the fuzzy set. So let's try to understand the fuzzy relation. Okay. And then we will see how to solve the problems using the fuzzy relations. Will that be okay, all of you? Yes. Everyone, am I
Yes,
audible?
ma'am.
Yes. Okay. So just a minute. I will share my screen. Just a minute, I am just sharing the screen. So all of you, please be ready with this. A quick confirmation. Is my screen visible?
Yes, ma'am,
Yes.
visible.
Visible. Okay. So what we are going to do now is, when it comes like a matrix, okay, like R and S is given, okay, wherein the x1, x2 are the rows, y1, y2 are the columns, and y1, y2 again are the rows over here, and z1, z2, z3 are the columns. Okay, I'll expand the screen, not to worry about this. Okay, so in such cases, we are going to see now how to basically uh, compute the max mean and max product composition. Okay, so two types of problems will come definitely on the fuzzy relation. One is called as a max mean and one is called as a max product composition. Okay, so let's try to understand this part. Okay, I'll just start with the presentation. Just a minute. Now is full screen visible to you all?
Yes.
Yes.
Discuss how to perform max min and max product composition on a given fuzzy relations with the help of simple solved example. In this case, we have been given two fuzzy relations R and S.
Okay, so first of all, I want all of you to note it down that we have been given the two fuzzy relations. One is the R and one is the S. So I want all of you to note it down, please. Is there anyone's coming? All of you note down these two fuzzy relations. So if you look at the fuzzy relations, it will be always like this. Okay, that is x1 and x2 are your rows, whereas the y1 and y2 are the columns. Now when we talk about the second fuzzy relation, obviously something should be common. And what will be common? That is a y1 and y2 over will be the rows, whereas the z1, z2, z3 will be the columns. Okay, write down these two fuzzy relations first. Done? Yes?
Yes.
Okay. So these are the two fuzzy relations which has been given to us. So let's try to understand what we need to perform. Okay. Everyone please concentrate and note it down. Again and again I'm telling you. Okay.
Given these fuzzy relations, we need to perform the max min and max product composition, and then we need to find the new fuzzy relation T in this case. So first we will discuss how to perform max min composition here. In this case, we have been given two fuzzy relations as said earlier, that is R and S here. Once we perform max min composition on a given fuzzy relations, let's say that R and S, we will get another fuzzy relation, that is T in this case. Now the question comes in front of us is how many members will be present in this fuzzy relation T here. Now if you look at these two fuzzy relations, the R and S, in this case you can see here x1, x2 are the rows, y1, y2 are the columns in this case. And if you look at these things, there are four members are there. Similarly in S, we have two rows and three columns. The meaning is six members are there here.
What would you tell a man who can scroll for hours but can't work for 10 minutes and hates himself for it every night?
And once you perform the max min composition or max product composition on these two fuzzy relations, what should happen here is the number of columns in the first relation should match with the number of rows in the second relation here. That is the minimum requirement. So there are two columns are there in fuzzy relation R. There should be two rows in fuzzy relation S here. Then only we can perform max min or max product composition here.
Okay, got it everyone, when we can perform it? Hello everyone. So when there are two rows, two columns, okay, and two rows, three columns, as I've told you that the two columns over here and the two rows over here, that is, these are the common things, then only we will be able to perform any kind of a max mean composition or the max product composition. Now looking at this one, when we are going to perform this max min composition on these two fuzzy relations R and S, we are going to get the new relation that is called as a T, and this is called as a R max min composition S. This is the symbol. So please try to understand this. You need to understand it very clearly even in the question paper as well. Okay. So what will be the output? The output that you are going to get will be something like this. Okay. So x1, x2, and then we will not have the y's over here. We will have the z1, z2 and z3. This is what we are going to get it. Okay. So how we are going to get that? Let's try to understand this. Okay. All of you, are you ready, all of you, with this? Hello? Yes. Okay. Let's.
So there is a match here, so we can perform in this case. Now the number of members in the fuzzy relation T is equivalent to the number of rows in the first column, that is x1, x2, you can notice here, and the number of columns in the second fuzzy relation, that is z1, z2, z3 over here. So that is what the number of members we will get in fuzzy relation T here. Now if you look at here, there should be 6 members. We need to calculate the membership values for all 6 members in this case. That is, first one is x1, z1, second one is x1, z2, third one is x1, z3, fourth one is x2, z1, and so on. I will discuss how to calculate the membership values one by one. That is, the first one is membership value of x1, z1 in this case. Now you can notice here, we start with x1 and we need to end with where? z1 over here. So that's the reason I have written the membership value something like this. The membership value of x1, z1 in the fuzzy relation T here, which is equivalent to maximum of. Next, we need to take the minimum here. The minimum between from where to where we need to go. We need to start at x1 and then we need to end at z1 here. So that's the reason we will start at x1 to y1. This is the first thing. We will get the first value here. The second one is what? We have ended at y1 here. We will start at y1 here. Now y1 to z1. You can notice here. We reach this z1. So what is the value we have here? This is 1. So between 0.6 and 1, we need to get the minimum here. This is the first one. And again, we need to start at x1. And then we need to end at y2 here. That is x1, y2, that is 0.3. Now we need to start at y2. And then we need to end at z1. That is y2, z1, which is equivalent to 0.8. So 0.3 and 0.8, between these two, 0.3 is the minimum here. So that is what I have written in this case.
Okay. Everyone got it? How to perform this now? Max mean composition. Please try to understand. That means inside that the minimum value, and then out of this minimum, whatever is the maximum that we are going to get it at this particular position. Now when we say that we need to start, we need to fill this particular value, that is a x1, z1. So how we will go? We'll start with the x1 and we need to end with the z1. What do you mean by this? So first x1, y1, that is 0.6. And then y1 and z1. We need to add at the z1. So what is the value? Over here it is a 1. So 0.6 and that is 1. Okay, 0.6 comma 1. We have to take the minimum out of this. Then again, what we need to do, tell me? Next will be x1 and y2. Okay, x1 and z1 we have to find out now. So x1, y2, that is 0.3. Okay, and y2, z1, that is a 0.8. So 0.3, 0.8. What is the minimum? So tell me which is the minimum out of this? So can I say out of this the minimum is 0.6, Out of this is minimum is 0.3, but from this to minimum, what is the maximum? It is a 0.6. So 0.6 will come over here in the new relation, that is a T. Is this clear? This is called as a max min composition. Are you with me, everyone? Hello?
Yes, ma'am.
Yes. So write down first of all this formula, how to find out, because we are not going to write down this formula again and again. Okay, again and again, in the sense, first we are going to find out for this one, so our formula will be this one. Next we'll go from x1 to z2. Okay, then the formula over here will change. Okay, so this is how we need to perform. Do it, all of you. First write it down, this one. Let me check if someone tries to come in. Do it. Once it is done, please let me know. How many of you are done? I cannot see your done. So can we start with the new one now? Hello? Yes.
Once you get those particular values, we need to get what? Maximum between these two is equivalent to 0.6 here. So this is how we can easily calculate the membership value of x1, z1 in this case. Now we will discuss how to find the membership value of x1, z2. That is, we need to start at x1 and then we need to end at z2 here. That is written something like this. Membership value of x.
Tell me now what we are doing over here. We have to come up to the z2. Tell me now x1 to z2. So x1 to y1 and y1 to z2. Am I right? So x1 to y1 is what? 0.6. Am I right? Am I right, all of you? x1
Yes,
to
ma'am,
y1
right.
0.6 and y1 to z2 is 0.5. So minimum out of this. Again, tell me what we'll do. Next is x1 to y2, that is a 0.3. Okay, and y2 to z2 is 0.4. So minimum out of this. Okay, so write down please a formula. That is like this you have written always. So x1 to y1 and y1 to z2. Same x1 to y2, y2 to z2. Okay, like this. And same way I want you to find it out for the z3 and let me know. I'm waiting. Do it.
0.3, ma'am.
Which one? x1 to z3?
Yes, x1 to z3.
Z3. Okay. So x1 to y1 is 0.6 and y1 to
0.5?
z3 is 0.3. So this minimum is 0.3 and then 0.3 and what is that? 0.7, again 0.3. So maximum out of it is 0.3. Correct. Very correct. Very good. So got it now, max min composition, all of you, how to do this?
Ma'am, got it.
Okay. Everyone, have you written this point? First of all, tell me, everyone. I'm waiting. Let's go for the next
x1
one. now.
z2 in fuzzy relation T here, which is equivalent to, again, we need to get a max of two minimum values. That is, we need to start at x1 and then we need to end at z2 here. So I will start at x1. I will go up to y1 here. What is the value we will have? That is 0.6. From y1, I will go up to here z2, that is 0.5. So between 0.6 and 0.5, what is the minimum we need to get? That's the first component here. Again, I will start at x1. I will go up to y2 here. What is the value we have here? 0.3. Now, from this y2, I will go up to z2 here. What is the value we have here? 0.4. So between 0.3 and 0.4, we need to get the minimum here. So minimum between these two is 0.5. Minimum between these two is equivalent to 0.3. The maximum between these two is equivalent to 0.5 over here. So that is the membership value of x1 z2 in the fuzzy relation T here. Now we will continue with the next one, that is how to calculate the membership value of x1 z3 here. We have to start at x1 and then we need to end at what? z3 here. So we will start at x1 here and then we will go to y1. What is the value we have? 0.6. We will start at y1. We will go up to z3. What is the value we have here? 0.3. Between these two, we need to get the minimum here. So that is what I have written here. Now we will start with again at x1. We will go to y2. What is the value we have here? 0.3. We will start at y2. We will go up to z3. What is the value we have here? 0.7. Between 0.3 and 0.7, we need to get the minimum here. That is what I have written here. Again, once you get the minimum between these two, we need to apply the maximum. We will get the 0.3 as the value here. This is the membership value at this place here. Similarly, we have to calculate the membership value for the remaining things. I have calculated.
Okay, so just check for x2 now. x2 to z1, how you will do this? Tell me.
Ma'am, second row cross first column of z1
And second row and this one. Exactly. So can I say now 0.2 and 1 right now? And then 0.9 and 0.8. Okay. So out of this, that whatever is the maximum. Then next one will be again same 0.2, but this one 0.2, and tell me what will come next row. 0.5 and then 0.9 and 0.4 out of this, right? Next will be 0.2 and 0.3 and 0.9 and 0.7. Got it, all of you? How to do this now? Max min composition. Yes or no?
Yes, ma'am. Very easy.
वेरी इजी ना, ये एग्जाम में सिर्फ आना चाहिए, कंफ्यूजन नहीं होना चाहिए बहुत सारे प्रॉब्लम्स देखने के बाद, राइट
वो फॉर्मूला लिखना इज कंपलसरी.
फॉर्मूला लिखना इज कंपलसरी, एटलीस्ट फॉर वंस you have to write it down.
This formula is complicated than solution, man.
Yes, but that is important, no? You have to go step by step, my dear.
Okay.
Okay. So final relationship,
here,
what you
these
will
are
get?
the membership values for the remaining three members in this case. And finally, the membership values for the fuzzy relation T looks something like this.
Is it clear? This is like this. Am I right? Hello? Right now?
Ma'am, right.
Yes. Okay. So we got the max min composition. We will go for one more problem and then I'm going to give you one problem for the solving. Okay.
This is how we can perform the maximum composition on the given fuzzy relations so that we will get the new fuzzy relation here. Now we will discuss how to perform max product composition on the given fuzzy relations.
The housewarming party is tomorrow, but the guests won't show up.
Ma'am, is
Again, we have been given two fuzzy.
हाँ बोलो.
max min में ratio of sets will be same 2 cross 2 or 2 cross 3. Something like this.
Something like this, but at least you should know that this and this should be proper.
Okay.
तो वो आपको चिंता करने की जरूरत नहीं है, वो एग्जाम पेपर में वैसे ही सेट क्या रहेगा. Exam paper will never have the wrong question.
Okay.
But if at all, you need to check this, right?
Yes.
So you should know how basically we need to go about this, right? Okay, before I go further, let me just give a quick confirmation. How many of you got this, the max-min composition? At least yes, no, something on the chat box, please. Everyone, I'm waiting. Okay. What about rest of them? मैं फिर से बोलती हूँ, जो बुक लेके सॉल्व करेगा ना उसको ही आएगा. जो सॉल्व नहीं करेंगे बैठ के, उनको ऐसे देख के नहीं समझ में आएगा. एट द टाइम ऑफ द एग्जाम यू विल बी टोटली कंफ्यूज्ड. आपको अभी इजी लग रहा है लेकिन एग्जाम में ऐसे नहीं होगा. एग्जाम में every problem will be there, so you should not get confused कि कहाँ पे क्या फॉर्मूला अप्लाई करना है. Are you getting my point? Hello. हाँ. Okay. So let's go for the now next same problem statement. Nothing changed, but instead of the max min composition, we are going to find out the max product composition. So let's see this one.
Relations R and S here. This is how the resulting fuzzy relation looks like once you perform max product composition here. Now we need to calculate the membership values at x1 z1 x1 z2 and so on. I will discuss how to calculate the membership value of x1 z1 here. So membership value of x1 z1 in fuzzy relation T is equivalent to max of, in the previous case we have taken the minimum, in this case we have to take the product over here. That's the only difference between max min and max product composition here. First we will start at,
so instead of taking the min, okay, max min, what was that? Max outside and the minimum inside. Instead of this, now there is a max product. So all of you first of all write down the formula. I'm waiting. So what you are going to do is x1 y1, okay, into y1 z1. Right now x1 y1 is 0.6 and y1 z1 is 1, comma x1 y2 is 0.3 and y2 z1 is 0.8. Take the product. Out of this product, whichever is the maximum that you have to take. First write down the formula, all of you at least once, and then we will go for how to solve this. Done? Have you written the formula, all of you? Written the formula?
Yes, ma'am.
Yes. Okay. So let's go for how to solve this.
at x1 we will go up to y1 here, that is 0.6. Again we will go from y1 to z1 in this case. What is the value we have here? 1 in this case. 0.6 multiplied by 1. So that is what the first component here. The second component is what? Again we will start at x1. We will go up to y2. From y2 we will go up to z1 here. That is 0.3 multiplied by 0.8 in this case. So once you perform those multiplications, you will get 0.6 and 0.
See now what we got? 0.6 into 1. Am I right? So that is 0.6 itself. Tell me what about this multiplication? What is x1 y1? 0.6. What is a y1 z1? It is a 1. So 1 into 0.6. You always better, instead of writing, you write down what is this one, that is a 0.6. Then what is this one? 0.3 and 0.8. Multiplication of this is 0.24. So what is the max out of this? Tell me. What is the max out of this?
0.24.
0 point. How come 0.24?
0.6, man.
0.6. What is the max out of this is 0.6. Have you written this? How to do this, everyone?
Yes, man.
Okay. So let's go for the next
to
one.
4. The maximum between these two is equivalent to 0.6 here. Now we will try to calculate the membership value at x1 z2 here. That is, we need to start at x1 and then we need to end at z2 here. So we will start at x1. We will go up to y1.
So you have to write down like this, always. So what is the x1? 0.6 and y1 to 0.5, comma 0.3 into 0.4. Am I right? So take the multiplication and get the maximum out of this. Are you getting my point, all of you? Hello? Max product composition, yes or no?
Yes, yes.
Okay.
Yes.
Wait. Same way, go for the entire thing and let me know what is the result. Then we will recheck. I'm giving you 3-4 minutes. Do it. If you have got this. Okay. So Raman has done this. Good. How many of you have done this?
Done, ma'am. Answer. I will
Done.
check.
Okay, so let's check this. Can we?
is the value we have here? 0.6. From y2, we will go up to where? z2. What is the value we have here? 0.5. 0.6 multiplied by 0.5. So that's the first one. Again, we will start at x1. We will go up to y2, that is 0.3. Now, from y2, we will go up to z2, that is equivalent to 0.4. 0.3 multiplied by 0.4, that is what I have written here. Now, the maximum between these two is equivalent to 0.3 here. Similarly, we can calculate the membership value of x1, z3. Again, we need to start at x1 till z3 we have to go. So x1 to y1, that is 0.6. y1 to z3, that is equivalent to 0.3. So 0.6 multiplied by 0.3, that is what I have written here. Next, we will start at x1, we will go up to y2, that is 0.3. y2 to z3, that is 0.7. That is what I have written here. Once you solve it, you will get the maximum value as 0.21. So that is the membership value of x1, z3. Similarly, we have to calculate the membership value for the remaining three things. That is what I have.
Okay, so those who have not done this, please write it down correctly. And just check what you are getting the final answer. Have you written this, all of you? This is the way in which you have to write down even in the exam. Again, I'm going to share this video link with you all. Even the last time's lambda cut also. Okay. Are you getting my point, all of you? So those who have not written, please write it down. Write it down properly. So this is the way in which you have to complete the max min composition and max product composition on the given fuzzy relations. Okay. Now these problems solve this very carefully. Okay. Little bit lengthy, but still you have to do it in a proper way. Okay. Once done, let me know. Done, all of you? Waiting for your responses.
Ma'am,
Calculated
that's
here.
done.
0.72, 0.36 and 0.63 are the remaining membership values here. Once you put all these membership values, the fuzzy relation P after performing
So T, you have to write down. Huh? You don't have to just write down this one. The final T will be like this. Is it clear? So this is how you are going to get your final T over here. Are you with me? Hello?
Yes, ma'am.
Yes, okay. So this is how basically we are going to perform the max, min and max product composition. So can we solve one problem based on this, all of you? Can we go for one problem?
Yes.
Okay. So before that, I'm just sharing Hira this link with you. Okay. Hira is there in the meet. Okay. Can you just punch me a hi message, please, if you can?
Yeah, sure. Just a minute.
So that I'll share this link and even the problem also after a minute. So this is the link. Okay. Link for fuzzy relationship problems. Okay. Now we will go for one problem based on this. Okay, just give me a minute. Just a minute. Huh? I'm sharing this. And then we will go for the De Morgan's law problem. Okay. Just a minute. I'll just share my screen now. Is my screen visible?
Yes.
Okay. So these are the two fuzzy set. I'll just expand it. Okay. So one is this one and one is this one. So you have to compute the two. That is a max min composition and the max product composition. I'm giving you a time of how much time? 5 to 6 minutes or more? Tell me. So do it. First find out the max min and then find out the max product composition. So write down the sets properly, write down the steps, every steps properly, okay? And then do this. Just a minute, someone wants to come in. Just a minute, someone wants to come in again. Those who have done, it's okay. I will wait. Let everyone complete this and write down step by step. Don't just give me the answers. In exam, again, I'm telling you, you have to write down properly. Okay. How many of you got the results? Have you written the relations now, all of you?
Yes.
Yes. Okay. Fine. The max min composition, the result is this one. Fine, let me just check.
मैम
Is this
एक बार फिर से हाँ.
huh? This is what you wanted?
Yes.
I will.
Done, ma'am. Noted.
Done. Okay. So let me just check. This is how you need to write down. Am I right?
Yes.
Okay. So first one is you got the 0.6. Am I right?
Yes.
Second is 0.5, then 0.6. Then for second row 0.3, 0.9 and 0.4. Am I
4.
right?
Yes,
Okay.
ma'am.
So the final answer for this one is this one. Am I right?
Yes.
How many of you got this answer? Let me know. I'm
Yes.
waiting. Yes, Sairaj has got it. Who else? Women has got it. What? Who else? Are you doing it? All of you, others? Yes, Abhishek. Very good. Okay, fine. And what about the product? Max product composition, tell me. This is the formula, am I right?
Ma'am, it is 0.14, 0.27, 0.10.
0.42, right? And then 0.4,
0,
0.48, 0.27,
27, 0.9,
0.90, and
0.36.
0.36. Am I right? This is the answer.
Yes.
How many of you got it? Tell me. आ गया समझ में अभी relations? Yes or no? Hello?
Yes, ma'am.
Yes. No? Okay. Very good. Now, this document also I will share with you all, the problem wherein given, so that it will be with you. चलेगा ना सबको?
Yes, ma'am. Yes.
Okay. So just give me a minute. I will share it with Hira. Where I was, data science, soft computing.
Ma'am, how many more formulas are there like this?
Now we have to go for that is this one. क्या बोलते हैं उसे? एक एंगल का है, एक डी मॉर्गन्स लॉ का है, बस that's it. Okay. So just a minute. Let me just check some more. Okay, and I will share. लास्ट टाइम हम लोग ने लैम्बडा कट का सॉल्व किया था ना. बाउंडेड सम का मैंने दिया था ना प्रॉब्लम हीरा. अगेन आई एम शेयरिंग.
Yes, okay.
I have given. No? Only the lambda cut is remaining, I think so. Just give me a minute. I will share that. Why I'm not finding the lambda cut? Just a minute. इतने सारे प्रॉब्लम्स हो गए ना यहाँ पे. लास्ट टाइम हम लोग ने लैम्बडा कट का प्रॉब्लम सॉल्व किया था. एनीवन?
Yes.
Yes, no. Let me just give you that. Give me a minute. एक ही मिनट है ना मुझे. आई विल शेयर इट, अदरवाइज ना वो क्या हो जाता है ना, रह जाता है फिर वो. ओके, जस्ट गिव मी अ मिनट. मुझे लैम्बडा कट का प्रॉब्लम देखने दो. कहाँ पे से क्या था मैंने. Give me a minute. I will share this. I got it. $2 minutes है ना मुझे. I'm sorry for wasting your time, but just give me 2 minutes, okay? फिर ना मैं बिजी हो जाती हूँ और फिर वो रह जाता है. Should not happen. Hira, again, one more thing, remind me, once we complete the fuzzy set now, I will share the question bank with you all, okay? So that you can start the preparation.
Yes, okay.
Okay, we will not wait till everything gets over. अभी टाइम टेबल आ गया है ना?
Date announced हुई है.
डेट तो अनाउंस हुआ है ना? दैट आई थिंक 17
16 हमारा है.
16th of June.
16
और इन लोगों का शायद से ये है
17 थे.
उनका होगा 17.
और सेम 2 का
हाँ, part 2.
पार्ट 2. मुझे उनका भी सब्जेक्ट है ना, क्योंकि I'm sharing both the problems, okay? Okay. Lambda cut
Ma'am,
का,
by the way,
हाँ
what
बोलो.
is this meaning of lambda cuts? What is
Lambda
this
cut
lambda
is
cuts?
basically it's kind of a threshold. So we are not taking everything from this, okay? So many a times what we want is something like this. So as and when you will proceed ना, जब भी आप I don't know whether you have this or not, but आप जब भी deep learning सीखोगे या whatever it is, okay? So we are not taking all that we got it. We wanted to take something above threshold normally, okay? So lambda cut is acting like a limit, or we can say lambda cut is acting like a threshold over here. Clear? Yes? Hello?
Okay, ma'am. Ma'am, last year you were on the teacher for soft computing.
Yes, yes. Why?
No, ma'am. Ma'am, this year please give more numericals.
Okay. So let's see. Let's start with this one. हर एक पेपर पैटर्न, हर एक क्वेश्चन पेपर का एक पैटर्न होता है. So we cannot go beyond that, right? और हमें नहीं पता ना कौन क्वेश्चन पेपर सेट करता है.
हम teachers ना.
That we don't know.
Do you know?
Let's see. So let's go for now the another type of the problem that that we need to solve it based on the fuzzy set, okay? And it's called as a De Morgan's law. So already we know what you mean by De Morgan's law. The only thing is we need to apply it on the fuzzy relations, okay? So what we need to show is A union B का complement is equal to A's complement intersection B's complement. This we have to prove this. Am I right? Are you getting my point? So we have been given the two relations. We can say the fuzzy relations. So x1, the membership is 0.1. x2 is 0.8 in the fuzzy set A. Are you getting my point? So instead of writing like this, मतलब ऐसे नहीं लिखा है हम लोग ने. Let me just check. See, we have not written that 0.1 by x1 like this. It is the same way. Are you getting my point? So ये relations ऐसे भी ध्यान रखना. It is like this. I will just show you. The pointer is not coming over here. So it is same like A is your fuzzy set, okay, is equal to, how you have written is, what is the membership has been given in the De Morgan's law? 0.1, right? So it is a 0.1 out, it is a x1 plus, what is the next membership? What was the next one? This one is 0.8. So 0.8 into x2. This is your, what we can say, the fuzzy set A. Are you getting my point, all of you? And then this is your fuzzy set B. What is the fuzzy set B has been given? It is 0.7 and 0.3. So 0.7 x1 plus 0.3 into the x2. Are you getting my point, all of you? Hello? Hello? Is my screen visible and are you here, everyone? Got it? How to write it down? So it is the same way we have written this. Okay, so do not get confused. So it is the same way. X1's ka membership in the A is 0.1 degree of membership, and X2 ka degree of membership in the A is 0.8. Same way we go for the X1's membership is 0.7 in the B, and X2 ka membership is 0.3 in the B. Okay, now what we need to do is we need to verify this. We need to prove this De Morgan's law. So let's see how we can do this. So first of all, tell me, can I say when I wanted to show that this is equal to this one, first I need to find out the A union B in the fuzzy set. Am I right? Hello? Hello? Am I audible?
Yes.
Okay. So now please try to understand these are the fuzzy set. तो tilde का sign either ऊपर या नीचे कुछ तो भी एक करना. This is a fuzzy set. So first of all, find out the union of this, and then the union का complement find out करना. So how to find out the union? Tell me. We have already done this. Tell me. Is it correct? So X A union B of X is equal to max of membership of X comma membership of B. Am I right? Hello?
Yes, ma'am.
Okay. So what is a X1? What is a X1 in the maximum membership? बोलो मुझे X1 का maximum membership क्या है? 0.7. Am I right? 0.1 और 0.7 में max is 0.7 और X2 का 0.8 है. So can I say A union B will be X1 0.7 and X2 0.8? Am I right? Am I right?
Right.
Have you written this? All of you write it down properly so that एक sum solve हो जाएगा अपना. हीरा और ये सब सम्स अभी नेक्स्ट जब भी सॉल्व हो जाएंगे उसके ऊपर एक 30 मार्क्स का आपको इंटरनल असेसमेंट रहेगा. 30 या 25 मार्क्स का.
Okay.
ओके पूरे सम्स रहेंगे एंड दैट यू हैव टू सॉल्व एंड स्टेप बाय स्टेप एंड यू हैव टू सबमिट इट.
So we have to submit handwritten notes, you're saying?
हाँ हैंड रिटन मतलब हाँ हैंड रिटन भी करते सकते हो.
नहीं, but what were you planning initially?
Yeah, I am planning like this. You solved it and convert that into the PDF. मतलब जो सॉल्व किया हुआ है. We have the scanners ना, डॉक स्कैनर वगैरह रहते हैं ना.
Okay.
Convert and tap PDF submitted. Otherwise, I will not come into the department and check. No?
Yeah, no, that's what I meant.
Hmm.
Okay.
I'll give you the instructions, everything. Okay. Okay, how many of you have written this? Tell me first of all. Have you written the formula? So we are finding first of all the A union B. So we got the A union B is like this. Am I right? Am I right, all of you?
Right.
Okay. Now find out the complement of this. So A union B का complement करना है. कैसे करोगे बोलो? So 1 minus 0.7 and 1 minus 0.8. So can I say A union B का complement in the fuzzy set will be 0.3 and 0.2? Are you with me? So first मैंने A union B find out किया फॉर्मूला से, उसका मैंने कॉम्प्लीमेंट लिया. सो आई गॉट A union B का होल कॉम्प्लीमेंट. द होल कॉम्प्लीमेंट इज 0.3 and 0.2. How many of you got this? Step by step we have to solve this. Done? Done or no?
Done.
How many of you have done? Punch me on the chat box. I'm waiting. Neera is done. Waiting for rest of them. Sairaj, what happened? Have you done it? No replies. What happened, people? एक ही प्रॉब्लम सॉल्व किया और दूसरा प्रॉब्लम सॉल्व कर रहे हैं हम लोग, डी मॉर्गन्स लॉ। करना है या नहीं करना है? हीरा, आई एम ऑडिबल ना?
Yes, we can hear you.
Why people are not responding? Okay. Now, once we got this, tell me what we need to prove now. That
Yes.
this equal to this. Am I right? Now, how you will do this? So, first find out the A's complement, then find out the B's complement, and then take the intersection of this. Am I right? So, what is the A's complement? Tell me. Can I say A's complement is this one? Do it. Step 3. So 1 minus 0.1 and 1 minus 0.8. Am I right? So we got the 1's complement as 0.9 and 0.2. I'm waiting. Same way, try to find out the B's complement. What will be the B's complement? Tell me. Step 4. Anyone who can punch me the answer for the B's complement? I'm waiting over here. B's complement. I'm waiting you to punch me the answer on the chat box for the B's complement. So you got the A's complement like this. Am I right? Is it correct? Is it correct? What is the B's complement? Tell me. Is it the B's complement? आ गया? Now take the intersection between this. बोलो क्या आता है इंटरसेक्शन का फॉर्मूला? Membership of A's complement comma membership of B's complement, minimum of that. देखो अभी इसमें क्या आ गया था? 0.9 and 0.3. So what is the minimum? 0.3 for x1. Am I right? Hello? क्या हो गया? एकदम से कोई रिस्पॉन्स ही नहीं आ रहा है बिल्कुल भी आपका. And what is for x2? 0.2 और 0.7 में 0.2. So what we got? This one. Am I right? 0.3 and 0.2. Now check. Is it correct? What we got it in the union is intersection. Is it correct? So 0.2 and 0.3 and 0.2. What we got it over here? Same over here. 0.3 and 0.2 here. So hence it is proved. Am I right? हाँ या ना?
Yes, yes, ma'am.
Same way, I want you to go for this one. अभी ये कैसे करोगे बोलो मुझे? Another De Morgan's law. A intersection B का complement. So पहले A intersection B find out करो, उसका complement करो, is equal to A का complement करो, B का complement करो, उसका union ले लो और check करो whether it is correct or not. I'm giving you a time to do this. Do it now. Do this. I'm waiting. Is it correct? So what is the union? उसका complement ले लो. Hello all, are you doing this? So what is a A union? A intersection B? This is a A intersection B. Am I right? Hello? Yes or no? Now find out the complement of this. So 1 minus 0.1 and 1 minus 0.3. So 0.9 and 0.7 is the A intersection B, the whole complement. Have you got the same thing? Have you got the same thing? अरे कोई रिस्पॉन्ड तो करो भाई, क्या करना ही नहीं है. हेलो, अभी ये फाइंड आउट करो. ए का कॉम्प्लीमेंट और बी का कॉम्प्लीमेंट फिर से फाइंड आउट करने की जरूरत नहीं है. अगर यही प्रॉब्लम पूरा का पूरा पूछा है तो ऑलरेडी वी हैव फाउंड आउट द एज कॉम्प्लीमेंट एंड बीज कॉम्प्लीमेंट. एम आई राइट? हाँ या ना? ऊपर ऑलरेडी फाइंड आउट किया है ना हम लोग ने, ए का कॉम्प्लीमेंट एंड बी का कॉम्प्लीमेंट.
Yes, ma'am.
Yes, so just go for finding out the union of this. That's it. So what you got, see, 0.9 and 0.7. So prove हो गया या नहीं होगा? हुआ, देखो. So verified है या नहीं है? So what we got over here, see, intersection 0.9 and 0.7. What we got over here, again same 0.9 and 0.7. Hence proved now.
Yes, ma'am.
So same way you have to do it the De Morgan's law. आ गया अभी समझ में सबको?
Yes, ma'am.
Okay. Yes, sir.
Yes, ma'am.
हाँ. So this is the way in which you are supposed to find out the De Morgan's law. So I'll be sharing the De Morgan's law का भी फाइल में शेयर कर देती हूँ सबको. So अभी एक दो टाइप के सम्स बचे हैं हमारे जो हम लोग नेक्स्ट करेंगे. एंड विद दैट, okay, there are some practicals based on this what we can say the fuzzy set. Let me just check a minute. Okay. एक तो डी मॉर्गन्स लॉ के ऊपर ही प्रैक्टिकल है हमारा. ओके, कहाँ गया आपका सिलेबस? जस्ट गिव मी अ मिनट. और वो होने के बाद then again we will come on to the first we'll complete the genetic algorithm वाला problem and then we will come to the first unit again. Okay, so कहाँ तक हीरा हम लोग ने प्रॉब्लम सॉल्व किए, हीरा और साइराज? सो हम लोग ने मैकलिच-पिट्स न्यूरॉन सॉल्व किया है, हेब्स रूल सॉल्व किया है, कोहेन एंड सेल्फ ऑर्गेनाइजेशन मैप किया है, हैमिंग नेटवर्क भी किया है. एम आई राइट?
Yes.
ओके, फिफ्थ प्रॉब्लम किया है हम लोग ने एसोसिएटिव मेमोरी का.
Bam wala, yes.
Okay.
किया है.
Yes.
सो फिफ्थ तक हम लोग ने किया है. ओके, अभी मैक्सनेट का जो प्रॉब्लम है दैट वी विल डू इट आफ्टरवर्ड्स, वन विल कम ऑन दिस वन. सेवेंथ प्रॉब्लम स्टेटमेंट इज ऑन द डी मॉर्गन्स लॉ. ओके, सो सेवेंथ प्रैक्टिकल है. फिर हम लोग को सेम यूनियन इंटरसेक्शन कॉम्प्लीमेंट हमें फजी सेट के ऊपर इम्प्लीमेंट करना है जो जैसे हम लोग ने किया था. सो दैट इज अ 8 प्रॉब्लम स्टेटमेंट. फिर से फजी रिलेशंस करना है हमें, उसके ऊपर कार्टेशियन प्रोडक्ट. ओके, एंड मैक्स मीन कंपोजिशन, मतलब ये सारे जो अभी हम लोग ने प्रॉब्लम सॉल्व किए हैं उसका ही हम लोग को पाइथन इम्प्लीमेंटेशन करना है. ओके, वेरी सिंपल है, कुछ भी कॉम्प्लिकेटेड नहीं है. सो वी अदर देन प्रॉब्लम नंबर 6, प्रैक्टिकल नंबर 6, 7, 8, 9 and 10 we will be performing it. Okay, and then we will go for the genetic algorithm. Is it clear to you all?
Yes.
Okay.
Yes.
So अभी प्रॉब्लम्स हम लोग को समझ में आ गए, उसको सिर्फ हम लोग को पाइथन में इम्प्लीमेंट करना है. सो वेरी इजी. सो वी विल नॉट गो टू द प्रॉब्लम स्टेटमेंट अगेन. ओके, सो नेक्स्ट Thursday, okay, whatever the session that I'm going to take. Tomorrow I don't have a time because I have the session, blockchain ka session in Mira. So with your seniors, so I'll not have a time. Thursday कुछ मिल Thursday नहीं, Wednesday कुछ time होगा तो हीरा बोलना मुझे.
Yeah, sure.
Okay, at least 1 hour का session मिलता है तो we will complete the fuzzy set का problem, and then Thursday we can complete all the practicals, remaining practical. Okay.
Okay, okay.
फिर एक हमें मंडे लगेगा wherein we will be going for the genetic algorithm. वो एक सेशन में खत्म हो जाएगा, उसमें कोई ज्यादा नहीं है. Okay, and then we have to come back again to the neural networks. Okay, so my plan is to complete your syllabus by the month end so that you will get some time. In between I will share the question bank as well, right? Everyone okay with this?
Yes, okay.
Okay, समझ में आ रहा है ना सबको क्या सिखा रहे हैं हम लोग? Yes or no?
Yes, ma'am.
Yes, good.
Yes.
So Hira, just take the attendance.
Yes, just a minute.
Okay, no issues. I'm ready.